Welcome back to another lecture. In this lecture, we're going to get an introduction and motivation for big data processing. So let's start with describing what big data means. Big data is a term used to describe datasets that are either too large in size, too complex in structure, or come to our system at such a high rate that exceeds the capacity of a traditional application to process it fast enough to provide any value. There are many characteristics of big data, but three of them are the most prominent. The first characteristic of big data is volume. Volume refers to the quantity of the data that we need to process, store, and analyze. When we talk about big data, we're talking about large quantities of data, typically in the order of magnitude of terabytes, petabytes, or even more per day. A few technology fields where we have a high volume of data include internet search companies that have to analyze the entire internet and provide instant search capabilities for their users. Another example is medical software systems that collect, analyze, and store a lot of information about patients in hospitals or clinics and can help in preventing or detecting diseases. Then we have real-time security systems that analyze multiple video streams coming from cameras located throughout certain neighborhoods, cities, or high-security facilities. The purpose of those systems is to help combat crime. Finally, we have the weather prediction systems that analyze a lot of data from different sensors located on satellites as well as in different locations throughout a large geographical region. Those systems can help us predict the weather as well as alert us about upcoming storms or tsunamis. The second characteristic of big data is variety. In traditional non-big data systems, we typically work with a limited number of structured and well-defined types of data. However, when we move to the field of big data, we can have a large variety of potentially unstructured data that we collect from multiple sources. Our goal is to process all that data and combine it together through a process called data fusion. This can help us find hidden patterns or provide business insights for our organization that aren't obvious if we analyze only one data source. An example of that are social media services or apps that collect a lot of different types of data about the behavior of their user base in real time. For instance, they can collect information about the user's clicks, likes, shares, or posts, as well as capture the amount of time a user spent watching a particular video or even hovering over an article or a digital ad. All those types of seemingly unrelated activities can be combined together and build models that can predict the behavior and response of each user to future ads of particular products. But also on an aggregate level, if we combine all that data from multiple users, we can detect internet trends as well as clusters of interest. Now finally, the third characteristic of big data is velocity. When we deal with big data, we normally have a continuous stream of data that comes to our system at a very high rate. The high rate of incoming data can be either due to the large scale of our system or simply the high frequency of events. For example, if we have an online store that operates on a global scale with millions of users visiting our website every day, browsing and purchasing our products, then the high rate of events simply comes from the fact that we have a very large number of users. On the other hand, we have the field of Internet of Things, which deals with connecting multiple devices and getting analytics from their sensors. In this case, we can have a relatively small fleet of buses, trains, or autonomous cars, but all those vehicles can generate lots and lots of data points from their sensors about their location, speed, surrounding objects, and so on. Similarly, we can have a food or clothing production factory which is full of robots, assembly lines, and other machinery that constantly generate data about their production quality and speed from their sensors. In both those use cases, the number of devices may not be large. However, each sensor on a robot, a piece of machinery, or autonomous car can generate a continuous stream of data points that we have to ingest very quickly. Now, it's important to point out that storing and processing big data is pretty complex as well as very expensive, but the value we get from it usually outweighs the cost associated with it. The insights we get from analyzing big data can provide a significant competitive advantage over our competitors. Those insights can come in a form of visualization, querying capabilities, or predictive analysis. Visualization is a very powerful tool that can allow humans to make sense of otherwise meaningless data stored in some file system or a database. In many cases, after we collect a lot of data, we don't necessarily know what to do with it or how we can benefit from it right away. So querying capabilities allow us to run ad hoc analysis on that data, which eventually helps us find those insights or patterns that were not obvious before. And finally, on the predictive analysis front, we can go as fancy as building algorithms or machine learning models to predict the behavior of our users and suggest products that they will more likely purchase. But we can also go as simple as detecting anomalies in our system by analyzing logs coming from our servers and automatically roll back a new release or alert the engineers on call. So now that we have the understanding and the motivation behind big data processing, let's proceed and learn about a few architectural styles that help us in processing and analyzing big data.